Now for the second point we're going to look at is we're going to ask for the pH after adding 10.00 milliliters of 0.1 molar sodium hydroxide. Now remember, we have, in this case, a weak acid and a strong base. This is one of the candidates for a buffer solution. So if we look at this, we have acetic acid plus NaOH in equilibrium with sodium acetate plus water. And remember that when we're adding different volumes of buffer solutions together, we want to look at the initial amount of moles, then the amount added, the neutralization, and then the endpoint. In this particular case, we're going to start with 2.5 millimoles of acetic acid because we have 0.1 molar acetic acid and we have 25.00 milliliters. So here we have 0.1 mole of NaOH per liter times 10.00 milliliters, which is going to give us 1 millimole of NaOH. So when we add to this particular solution, we're going to add 1 millimole of sodium hydroxide. In the neutralization step, we're going to use up this 1 millimole because we have 2.5 millimoles of H plus and only 1 millimole of OH minus. So one of these millimoles are going to be neutralized. We're going to end up with 1.5 millimoles of acetic acid. There isn't going to be any sodium hydroxide left, but in that neutralization step, we're going to produce 1 millimole of sodium acetate. So we get 1 millimole of sodium acetate left. Then we can use the Henderson-Hasselbalch equation, which is going to be the pH is going to be equal to the pKa plus the log of the concentration of the A minus divided by HA. This means our pH is going to equal the pKa, which remember for acetic acid the Ka is going to be equal to 1.8 times 10 to the minus 5, which means the pKa is 4.74, or the negative log of that, plus the log of the concentration of the A minus, which will be 1 millimole divided by 35.00 milliliters, divided by 1.5 millimoles, also divided by 35.00 milliliters. So the volumes here are going to cancel out, and when we do the math, we're going to get the pH is going to be equal to 4.56. And this is going to be the pH after adding 10.00 milliliters of 0.1 molar sodium hydroxide. So now let's add a little bit more sodium hydroxide and see how the pH is going to change.